Hello, my dear students. Welcome back to the lecture. So the next lecture is that what is the minimum percentage of a steel that you put it in the column? We understood what is the minimum diameter of the bar. We understood the minimum number of bar in the column. Now, how much amount of steel you are supposed to provide, that we need to understand. Okay. So actually, it is 0.8% of gross sectional area. Remember the term 0.8% of gross sectional area. Gross sectional area in the sense whatever is your size of your column. Let us say I'm taking a column now. Okay, this is my column. Okay, I'll do in this way, and let us say this is 230 mm, the breadth side. This is 230, and let us say this is 500 mm. Okay, so this is my gross sectional area. How do you find the area? 230 into 500 is going to give me the gross sectional area. Got it? Yeah. And what is the maximum percentage of the steel in the column? Okay, now we understood the minimum. They are going to ask this question, and this is one of a good question what an interview can ask. Even if you go for a structural job junior level, you can expect this question. Okay, and how do you calculate this? I'll tell you how to calculate this. Very simple. Do that 0.8%. So I'll do 0.8 divided by 100, 0.8%. No, multiply by the gross sectional area, that is 230 by 500. Can you do it? Tell me what is the answer you're getting. So I'll do it. 0.8, no? So 0.8 into 230 into 500, 92,000 divided by 100, 920 mm. So 920 mm square. This much area of steel I'm supposed to provide. This much minimum steel I have to provide if I'm giving a column of 230 by 500. So how do you decide this 920? Again, I have explained all these things in my construction methodology course, in the ETABS course and all. We know the diameter of one rebar. Let us say if I take a 16 diameter bar, what is the area of a 16 diameter bar? The area of a 16 diameter bar is 201. What is the area I'm supposed to satisfy? 920. So what you're supposed to do? 920 divided by 201. Tell me how many number of bars you're going to get. If I divide it by 201, I'm getting 4.5. So I can consider this to be 5 bars. So I need to provide how many bars? I need to provide 5 number of bars in this column. Minimum I need to provide 5. Okay, minimum 4 we have to provide. By our calculation we got 5. But practically, is it possible to provide 5? We'll do that. It's not possible. Why? Because how will I provide 5? I'll provide 1 here. I'll provide 1 here. Okay. Second, I'm going to provide here. Okay. Third, I'm going to provide here. Okay. Fourth, I'm going to provide here. Good. Another one. Okay, I'll provide it here. Good. What about this side? You should provide another bar, no? Otherwise, how you are going to tie that lateral ties and links? So always remember, yeah, one more question will come. Always remember, in the column, you have to give even number of bar. Even number of bars. What is even number of bar? You cannot give bar like 1, 3, 5 number of bar. Even in the sense, how much it comes out to. You have to give minimum 4 you have to give. What is the next even number? 6. Next even number 8. Next even number 10. Next even number 12. Got it? So in this way, you're supposed to give. We got the answer 5, but we cannot give 5. We have to give 6. 5 bar actually it is required, but we are not going to give. Why? From detailing point of view, from execution point of view, it is not practically possible. So we have to give how much? We have to give 6 number of bar. From steel point of view, it is not required. From taking load point of view, 6 bar is not required. 5 is sufficient. But from execution point of view, 6 number of bar is required. So I'll provide 1 more bar in this place. Got it? This is how you're supposed to do it, right? Yeah. This much is understood. Next, maximum percentage of, now you understood minimum this much you have to give. What is the maximum you can give? So first, you can give 6% of cross-sectional area. When you can give 6% of cross-sectional area, when no lapping is done. I told you that when you're using a diameter of a bar like 32, 36, if you cannot do the lapping, you can make use of couplers. So whenever you're making use of couplers, you can give 6% of the total cross-sectional area. I'll do the manual calculation and show you. Next, if you're giving lapping, if you're doing lapping, if you're going to do the lapping, then you have to restrict it to 4% of the gross sectional area when lapping is done. Okay. If no lapping, 6. If you're doing lapping, it has to be 6. But both these are only on the paper, or are both the value like 6 and 4 are only on the code book. Practically, it's not possible to go up to 4. but practically we keep 2 to 3%. 3 is also on the higher side, I'm telling, but 2.5 is a good percentage of a steel you can keep it in the column of a cross sectional area when we design and detail the reinforcement. Got it? So all these things you get from the ETABS. When you do the analysis in the ETAB, ETAB will show for this particular column how much reinforcement is coming. If it is coming like 3.5%, what I'm going to do, I'm increasing the size of the column, so that the moment I increase the size of the column, the percentage of the steel is going to come down. Got it? Very simple. So I try to keep the column reinforcement in between 2 to 3. Got it? Now I'll do all the manual calculation for this. So if I take 6%, how much it comes out to be? Do it. 6 divided by 100. I'll multiply this by cross sectional area, which is 230 by 500. Do it. What is the maximum you're going to get? I'm doing. Okay. I'll do 6 into 6%, 6 into 230 into 500, and I'll divide it by 100. No, 6,900. So 6,900 practically not possible. This much steel will, I mean, this much we can give if you're not doing lapping. Like I mentioned, it's only on the paper, practically not possible. So where shall I keep it? I'll reduce the size. Yeah. Okay. Yeah. Next. After that, next is 4%. So 4 divided by 100. Multiply this by 230. Multiply this by 500. Okay. Because column size remains the same. So again, 230 into 500 into 4 divided by 100. 4,600 mm square. Mm square. Right. So again, it is on the paper. So practically what we do, 2 to 3%. So we'll go with 2. I'll take average. I'll go with 2.5%. So 2.5 divided by 100. I'll multiply this by 230. Multiply this by 450. Do it for me. What is that? 2.5 multiplied by 230 multiplied by 500, and you divide it by 100. That's it. 2875 mm square. This much steel only we are going to give. Okay. This much steel only we are going to give in this column. Now you decide for 2875 how much amount of how many number of bars will come. On this, if I do this, how many number of bar will come? Again, I'll go with the 16 diameter bar only. Okay. I'll go with the 16 diameter bar. Area I need to cover 2875. I'll divide it by area of 116 diameter bar, which is 201. You can take 20 also. Again, now you are an engineer. You are a structural engineer. You can go with 16. You can go with 20. You can go with 25. The moment you increase the diameter of the bar, the number of bar will come down. Very simple. I'll go with 16 only. It's 201. So this will go almost 12 number of bars. So 2875 divided by 201. I'm getting 14.3. Let us say 15. 15. Okay. Yeah. I'm getting 14.3. We always take it to the next higher value, which is 15. Practically 15 is the odd number. I have to go with the even number. So the next higher is 16. So I'll go with the plus 1, 16. So that means practically I need to provide 16 diameter, 16 number of bar in this column. Now, is it possible to provide a 16 diameter, 16 number of column in the size of 230 by 500? Practically not possible. Why? Again, so you can provide, but practically on the size site, when you pour the concrete and when you run the vibrator, your concrete doesn't go. There's so much of congestion. Now, what you can do, increase the increase the diameter of the bar. So instead of 16 diameter bar, I'll go with the 25 diameter of a bar. The area of 125 diameter bar is 489. Now you got the importance why I told you to understand or to remember the area of one bar. I told 8 mm it is 50, 10 it is 78, 12 it is 201, so 12 it is 113, 16 it is 201, 20 it is 314, 25 it is 489. I'll do it. Okay. Say it is 25 into 25 divided by 162.5. Yeah. No, sorry. Wait, I'll do it. Pi by 4. Pi by 4 into d square. 3.5 by 4 into d square. D square is 25 into 25. Yeah, 490 I'm getting. 490 I'll consider. Okay, 490 mm square. You're getting what I'm trying to do. This is what happens in office of a structural engineer. This is how we try to do. So if you know all these things, you can rule on the site. Yeah. So what is the area I'm supposed to satisfy? 2875. I'll divide it by 490. Let me do that. 2875 divided by 490. 5.84 we'll consider 6 number. Okay. See, I'm getting 5.84. So next round, next higher value is 6. Now for 6, again, I will not add 1 because 6 by default, I got it as even number. It's not odd number. If I had got 5, then I would have added 1 to make it as an even number. Already by default, I got 6. So practically, is it possible? Of course, it is possible. In a 230 by 500, see, already I've provided 6 bar. You can see here, no? Okay, 1, 2, 3, 4, 5, 6. And then I can write all these things, okay? All that, what you call, yeah, all those things I can show in this way, okay? That, I can write here and say, you have to provide, what is that? 25 diameter, 6 number of bar. It's understood. It means that in this particular column of 230 by 500, you have to provide a 25 diameter, 6 number of bar. So this is how we are supposed to do all these calculations and all, right? I think most of the things I have covered. See, whatever I'm telling you in this level, you don't expect these questions will be asked in the interview. But if you're going for a structural consultant, if you're working as a, if you're applying for a junior designer and all, then you should be knowing all these things. But if you know, it's well and good, always well and good, because many people don't know. So I taught you what you are supposed to understand, what you are supposed to take out from this course is 0.8% of cross sectional area is a minimum still, 6% when there is no lapping. If you're doing lapping, 4%, practically 2 to 3%. Again, this you should not tell them, okay? You should, because even this, many people don't know this too, because if you're not worked as a structure consultant, you don't know that. So people have that belief in the mind that we go with 4%. Practically, we don't do that. So you just stop your answer only up to here. You should not go this, because it doesn't know that. Then you should not tell that, or you should not tell all these things in the interview. Whatever is there in the book, no, that only you have to tell. All these things you have to understand so that you can guide someone, right? That's how it is. Yeah, that's it. Most of the questions we have understood. I taken 0.8% of cross section area, told you the manual calculation. Maximum is also done. Yeah. Yeah. So one more, yeah, anyhow, spacing will come to the later part, not now. Okay. There is one thing which I wanted to tell. I'll explain here. Maybe when I teach you the code book, I can take that. Yeah. So like I mentioned, we are supposed to provide this rebar, no? Like, wait. I'll go with the, yeah, this thing. Yeah. See, now there's one more thing you need to remember. The thing is that the spacing between these two rebar, the spacing between this two rebar should not be more than 300 mm. Okay. Should not be more than 300 mm. That means whenever you place the reinforcement bar, no, the longitudinal bar, the spacing between the two should not be greater than 300 mm. Got it? Spacing should not be greater than 300 mm. So what is the practical use of this? I'll tell you. Let us say you design one column and you got that, wait. Okay, I'll strike out everything, okay? Yeah, let us say you design one column. Okay, you designed one column and you gave a reinforcement in that, okay? You gave a reinforcement in that. So again, I'll take this. It is a 230 by 750 column. 230 by 750 will consider. And you give a reinforcement. Let us say you give one here, like whatever diameter it may be. Another one you gave here. Okay. Another one you gave here. Another one you gave here. So this much is sufficient. This much still is, because minimum criteria is satisfied. 4 number of bars you are given, done, and this much is sufficient. And you are okay. But I told you the distance between the two bars should not be greater than 300 mm. Now you see here what has happened. So what has happened in between these two rebar? What is the spacing coming out? Overall, it is 750. If I take out the cover and all directly, I'll do it for you. So 750 is the overall depth. It's a column, right? So you take 40 mm cover out from the top, 40 mm from the bottom. Then you have a stirrup of 8 mm. Then let us consider this is my half of this and half of this. You're getting my point? See, we are going from center to center, okay? Center to center. 750 minus cover 40 mm from the top, minus 40 from the bottom, okay? Then a stirrup minus 8 mm on from both the side, okay? From both the side, I'm taking it out. Minus, you can see this distance, no? I've taken it from the center. If you can observe it here, I'm trying to be more precise. If from this center to this center spacing we want, okay? Center to center, okay? So if this is a 16 diameter bar, half of this is 8. So this will be from this center. If this is also a 16 diameter bar, half of this is 8. So 8 plus 8 is 16. So what I'm going to do, 8 plus 8 is 16. So I'll directly minus 16 from this. Okay. Tell me how much you're getting. You'll get more than 300 only. It's very simple. 750 minus 40 is minus 80. And 8 is 16. 16 is 32. We're getting 638. 638. So this 638 mm is greater than 300 mm. So now your spacing criteria is not matching. Even though there is no requirement of any bar, this is satisfied to take care of the load. From detailing point of view, from code book point of view, you have to give additional steel. Then what you do? You go with a very lesser diameter of a bar. What is the minimum diameter of a bar you're supposed to provide? 12. So we'll provide additional 12 diameter bar, which is actually not required. But from spacing point of view, I'll give one more bar here. I'll give one more bar here. Got it? That's how you're supposed to do. Again, this is from detailing point of view. What happens in a structural engineer office. But you should be knowing what is the maximum spacing and that you're supposed to keep. That is why I've taken up this. Yeah. So I hope you have enjoyed the lecture up to here. We'll see you back in the next lecture.